All right. I need to be able to see what y'all are seeing there. Y'all, that's Southern California for everybody. Y'all. Well, it's good to be here. I think it's my 5th time visiting London, and it's one of my favorite cities. Edinburgh is right up there as well, and I'm going there next, so I'm really happy about that. Anyway, I was asked to speak first lesson about God and science. Let me give you a little bit of my background. I grew up going to a traditional Christian denomination, the one that broke away from the Anglican Church, you know, the Episcopalian Church. We kicked out the king, and then we kicked out the king's church. So I grew up Episcopalian. I was the guy who carried around the candle and all. No. Just house lights on, these off. Is that possible? House lights on? That has to be possible. Every lecture hall, it's possible to turn down those lights. I know it is. But it may not be possible tonight, which is fine. It's fine. So anyway, so I was the president of the church youth group, but there was one minor problem. I didn't believe in God. Apparently in that church it didn't matter too much about that. I remember we had a debate when I was, and I took the no, there is no God position in that debate at our youth group. Went off to college, and I was a declared atheist. I remember persecuting the Christian guy in the dorm there, and I remember taking Nietzsche, studying philosophy. Nietzsche said God is dead, and I was sort of fired up about that. Now, at this point, I think Nietzsche's dead, and God's doing okay. But anyway, at some point, through studying science as a chemistry major, I came to realize there was a God. And so I began a search for, which God? I was mostly interested in Eastern religion, Hinduism, Buddhism, mysticism, those kind of things. But then finally, my first year in graduate school, I started reading the Bible, and I came to the conclusion that the God, the real one, is the one that's mentioned in the Bible. So what I'm going to do in this talk, there's really 2 parts, God and science, which is a little discussion of why I, as a scientist, say that I have to believe in God. And the second part will be more specifically about science and the Bible, science and Christianity. Okay, so I'm going to consider 2 possibilities. You can read that despite the fact that it would be nice to have these front lights down. I know it's possible, but all right, that's fine. You can read it. Because if we turn that off, then I can't see you, and then I don't know, whatever. So, this is Thomas Huxley, good friends of Charles Darwin. He said, "We are as much the product of blind forces as is the falling of a stone to earth, the ebb and flow of the tides. We've just happened, and man was made flesh by a series of singularly beneficial accidents." So one view is, it's just an accident. Another person to describe this atheist perspective would be just up the road there, and you've probably heard of him, Dawkins. You've probably heard of him. His take on this question, he said, "In the universe of blind forces and genetic replication, some are going to get hurt, others are going to get lucky. You won't find any rhyme or reason to it, nor justice. The universe we observe, it has precisely the properties that we should expect if there is at bottom no design, no purpose, no evil and no good. Nothing but blind, pitiless indifference. DNA neither knows nor cares. DNA just is, and we dance to his music." That's one perspective. I have to say it's depressing if it's true, but perhaps it's true. And many give the impression that this is the scientific perspective on the question. And I want to protest against that. I don't think that it's obvious. And he makes this claim. He makes this claim that if you look at the universe, it's obvious that there is no purpose, no design. Okay, another perspective would be quite the opposite, which is the evidence says there is design, and there's a designer and a creator. William Paley described that. He used the watchmaker argument. That's a bit outdated. How about the cell phone argument, okay? Something like this, you're going down the street, you see a cell phone there, and you're thinking, man, how'd that thing get there? I don't know. Maybe there's some metal and some dirt and plastic and, I don't know, cars bumped over it, some rain. Cell phone! Now, that would be crazy, right? That would be insanity to believe that that's the case. But I'll tell you this, from what we know about life, the simplest conceivable living thing is vastly more complex than that, don't look down, there's no cell phone there. Right. Than that metaphorical cell phone there. And yet some people believe that life could come about by, a singularly beneficial series of accidents. I don't think that's a rational view. In fact, rather than using the cell phone as a illustration, I like this. Let's imagine you have, say, a junkyard. And I could say a tornado. Do they have tornadoes here?
Yeah.
All right, a tornado. So you got dirt and metal and wood and blah. This thing rushes through there, and out pops a 747. Yeah. What do you think? Because to be honest with you, I think that's a better illustration of what we're talking about. So what I'm going to do is I'm just going to give a very brief run-through. I teach physics and chemistry, so I'm going to look mainly at physics and chemistry, a little bit of biology, talk about some reasons why I, as a scientist, say the only rational conclusion from the information is that there's a God. So I'm going to start. Now, hopefully, if you have the, let me see, the H and the O and the H, you don't need the label there. Hopefully you didn't need that. Okay, got it? Now, in order for life to exist, there has to be a liquid. A solid cannot be the substance from which a living thing is made. A gas certainly can. It would have to be a liquid because, chemicals would have to move around. And that liquid would have to be able to dissolve a very wide range of molecules. And also, scientists would tell you that life cannot exist below maybe roughly minus 20 centigrade because below that temperature, chemical reactions simply don't go fast enough. And above maybe 80 to 100 degrees centigrade, it's too high a temperature, small molecules fall apart almost immediately. So a fairly short temperature range. And so there are very few compounds that are liquid within that temperature range, but it turns out only one of those compounds has this wide variety of molecules that dissolve. Water dissolves a wider range of substances than any other. In fact, without the ability to dissolve ions, life could not exist. And water is the only substance that dissolves ions that's liquid in that temperature range. Only one. You could teach an entire one-semester course about the properties that are unique to water. No other molecule has them. And each one of those properties, if water didn't have those properties, there'd be no life. Some people say blind, pitiless forces, without meaning. And I say that doesn't seem to fit the evidence. So let me talk about some of those properties. One, of course, is its property to dissolve a wide range of substances. Now, water dissolves a wide range of organic substances, dissolves a wide range of ionic substances, but it doesn't dissolve all organic substances. Luckily for us, otherwise we'd be a puddle. That wouldn't work out so well. Also, it has the right boiling point. Another thing about water, of all the substances in the universe, water has the highest specific heat. It's 10 times more than most substances, 2 or 3 times more than all other substances. The same substance that has the right solvent properties, also has the right boiling point range, also is the substance that absorbs the most heat. All right, why is that important? Well, if any other substance was the substance on which life is built, then the temperature of the Earth would go up and down by 200 or 300 degrees centigrade in any given year. Again, no life. Water has a number of other interesting properties. Now, I used to live in Wisconsin. It's a really strange place because in Wisconsin, they can actually walk on water. In the winter, all right. That works better in a tropical country here. It's not surprising. Anyway, now there's actually 2 things. It gets a little complicated here. Every substance in the universe has the property that as you warm it up, its density goes down. One substance, the only exception, is water. Water has this strange property that its density goes down, and then at 4 degrees centigrade, it goes up, and then it freezes, then it drops like that. Another property the water has is that the solid floats with the liquid. You knew that, right? Did you know there's only one compound of the millions of compounds? There's only one of the millions where the solid floats on the liquid. You say, well, okay, fine, whatever. Not whatever. Because if it weren't for those 2 combined properties, then in the winter, lakes would freeze to the bottom. All the fish would die, not so bad. Except during ice ages, the oceans would freeze, and all life except maybe the simplest conceivable life would have disappeared. Anyway, we could talk about the viscosity of water, et cetera, et cetera, et cetera, the surface tension of water, the electrical conductivity of water, the heat conductivity of water, et cetera. Some people would say a large series of singularly beneficial accidents. I would say God. All right. There we go. Some of you are breaking into a cold sweat right now. All right. Now, I teach chemistry. I tell my students that Mendeleev invented this chart. Actually, it's not true. Guess who invented this chart, at least from my perspective? God did. His fingerprints are all over this chart. There are at least 20 elements that I could list that have a property that no other element has. And if that element didn't have that property, we wouldn't be here to even be talking about it. All right. Somebody with a little chemistry background, which element am I going to start with? Carbon. Very good. Carbon. I teach organic chemistry. The first 2 days when I teach the class, I spend on all the properties that are unique to carbon. We spend 2 semesters doing the chemistry of carbon, and then 1 semester doing the other 91 elements, and there's a reason, because of those unique elements that carbon has. And every single one of those elements that carbon has that no other element has, if carbon didn't have those properties, there'd be no life. Okay, one of the properties that carbon has is it forms 4 bonds. All right, so what's the big deal about 4 bonds? Well, until you get 4 bonds, you don't have 3-dimensional molecules. And if you don't have 3-dimensional molecules, obviously you don't have life. It turns out carbon's not the only element that forms 4 bonds. There's actually 2. That's carbon and silicon. The problem is with silicon, if you form a molecule with 2 silicon atoms connected, it explodes. Not a good choice for building life. Okay, I'm not going to give you all those properties of carbon that are unique to carbon because it's going to probably bore you a bit. Another very important property of carbon is it's the only one that forms large molecules. Well, lucky for that, eh? Yeah, otherwise, clearly it wouldn't be here. Okay, we could go back, other elements in the periodic chart. Again, helium, hydrogen, copper, et cetera, et cetera, et cetera. I'll go with iron for a second. Now, iron has one very important property, which is it's the only element which forms a strong magnetic field. All right? Otherwise, how could you put your homework up on the refrigerator, right? That's not why it's so essential. Turns out the sun produces a range of radiation. Now, luckily for us, almost all the radiation from the sun is visible light, because visible light has the property of being able to initiate chemical reactions without destroying chemicals. Luckily, something around 90% of all the radiation from the sun is in the visible range. But there are 2 kinds of energy that come from the sun that would destroy all life. And one of them is this high-energy particles, the electrons and the protons. That's why if you're going to take a mission to Mars, that's a big problem. But it turns out the magnetic field on the Earth literally is a force field that deflects all those particles. Now, it's not just that iron is magnetic. Not only is iron magnetic, it also has the unique property of being the most stable element. All right, and for that reason, it's not only is it the only magnetic element, it's also the most common element in the Earth. The Earth is mostly iron. And if it wasn't both the most common element and the only magnetic element, there'd be no life on the Earth. Singularly beneficial accident. I would say so. Singularly beneficial, but I don't think an accident. Okay, then we could talk about, let me see, we could talk about oxygen. The other kind of radiation from the sun that's deadly to life is ultraviolet. Now, we could go on and on about oxygen, which is the only element that can support a high metabolism life form, but it turns out there's 2 kinds of oxygen. One is the only one that supports high metabolism life forms. The other one's poisonous. Luckily for us, it's only formed in the upper atmosphere, ozone, and it protects us from UV radiation. Nice design element there. Okay, I could talk about uranium. Now, you probably think uranium is dangerous. I don't think you want it scattered around your house. It is dangerous, but it's also essential to life. Because the property that's unique to uranium is the only radioactive element in any significant quantity which has a sufficiently long half-life. Now, scientists would tell you the Earth is roughly 4.5 billion years old. And uranium-238 has a half-life of roughly 4.5 billion years. Why is that important? Well, if it were not for uranium, and by the way, uranium is very dense, so guess where most of it goes? To the center of the Earth. Lucky for us. Again, lucky for us. And it produces heat. If it were not for uranium, the Earth would be solid and cold all the way to the center. No problem, right? Well, kind of a problem, because then you don't have plate tectonics. And then the minerals in the Earth would not get recycled. The surface of the Earth would be barren of life other than perhaps the simplest life. Oh, by the way, we would also have no atmosphere. So you don't want to live on a planet with uranium? Great, go to Mars. There's almost none. And of course, not a whole lot of life there either. All right, anyway, I could talk about hydrogen and helium, but you get the idea. All right, now I want to talk about DNA. And it's kind of geeky and weird, but when I think about DNA, it kind of, if I had hair, it would make it stand up. I mean, it's an amazing invention. It's a spectacular invention. And what DNA is, it's a code. Those nucleotides, C, G, A, and T, they're a code, and 3 of them codes for a protein, for amino acid to make a protein. Now, do you believe by random molecules bumping into each other, a code could be created? You have to believe that if you're an atheist. To me, I don't believe it. And I certainly like to see that shown in any kind of experiment. I'm sure it won't be. All right. Now, think about the amount of information. Nature creates order. It's fantastic the amount of order that nature creates. Let me show you a slide that kind of shows, the kind of order that nature creates. That's pretty spectacular. But nature never creates information. There are no exceptions to this rule. Nature does not create information. How much information in the simplest living thing? Well, going the wrong way. Let's go back. Okay. Humans have about between 2 and 3 billion base pairs. But as a model for the simplest life, that's way too complex. Something like E. coli, 100 million, cut it in half, 50 million, cut it in half again, 25 million. Could a life form exist with 25 million pieces of information? Maybe. I'll use that as my baseline. That's the amount of information in 2 or 3 novels. So the probability of that amount of information being self-assembled, never mind the whole idea of making all these molecules, never even mind that. It'd be like taking 25 million letters, throwing them in the air, and when they fall on the ground, you could read it like a book. That's impossible. There's a mathematical definition of impossible rather. And I don't remember that number. Somebody could maybe tell me, but I think it gets to that level. There's people who actually believe this. Sometimes, we're criticized as believers. Well, you have to be able to believe in almost anything. All right? I admit it. We have to be able to have faith in things that are sometimes difficult to believe. But the faith to believe that these things could have happened by accident is mind-boggling to me. I don't understand it. But I'm barely getting started. Now, here's the deal. What DNA does is a code to make proteins. Proteins do all the work in the cell. All the DNA does basically is maintain the information. The thing is, the only thing in the universe that makes proteins is DNA. And guess what the only thing in the universe that makes DNA is? Proteins. So not only does the atheist believe that these 25 million pieces of information came together spontaneously, with sufficient information to create a living thing, more information than in any 747. But not only that, but at the same time, the proteins that would have been made by that DNA had to also be made and be in the same cell. All right, that's complicated. But there's people that actually believe that. I don't, personally. I'm going to skip a few slides. All right, let's talk about physics a bit. Now, physicists before the 1940s or so were unanimous on this point, which is the universe had existed forever. Steady state theory, or whatever you want to call it. And why is that? Is it because evidence pointed towards an eternal universe? Answer, no. The reason physicists tended to believe in the eternal universe is because of the philosophical implications of a non-eternal universe, which is creation. So the belief the universe was eternal was not the result of any scientific thinking, but because of a philosophical presupposition against religion, essentially, is what it comes down to. All right? Of course, the Bible had said all along, such as in Hebrews 11:3, by faith we know that things that are seen were made from things that are unseen. Or that, the universe was created. And then you know the story. I'm not going to talk about the discovery of the expanding universe and the redshift. And what's interesting there is what physicists tended to do after they discovered the universe was expanding, they think, well, that's kind of scary. Because if it was expanding, it must have had a beginning, so they came up with this idea that the universe is expanding but continuously creating new matter. Well, where did that come from? From a desire to save the idea of an eternal universe. But then Penzias and Wilson discovered the microwave background radiation, and there's all this other stuff. The bottom line is, the evidence, slam dunk. It appears that the universe was created for nothing. In other words, there was nothing. No matter, no energy, no light, no space, nothing. And at one instant, let there be light, a flash of light, and the universe came from nothing. So science caught up with the Bible, finally by about the 1950s, or really the 60s. All right, and then there was the idea about just the properties of the universe. So scientists began to look at this Big Bang model, which seems to accurately predict the properties of the universe. Does that mean it happened? I don't know. I honestly don't know if it happened. I wasn't there. I don't know, but evidence points in that direction. So as they were modeling this, it turns out, of course, this expansion event occurred, but then gravity resulted in that matter clumping, producing galaxies, stars, planets. And what they discovered, to their amazement, now would you agree that's a small number? All right. 59 zeros and then a 1. Does that, like lottery? Yeah, they have a lottery. Right? It's kind of famous, actually. Yeah. Now, what would be your reaction if your friend won the big lotto? Yeah. Now, what if they won it again the next time? And the next time? Yeah. And the next time, and the next time. They're in jail, right? Right. Because that's impossible. Right, that's my point. Because what they found out is, if you sort of tinker with the force of gravity, if you make the force of gravity bigger than it is by that fraction, the universe would have collapsed almost as soon as it was created. If the force of gravity was smaller than it is, by that fraction, it would have expanded forever and galaxies never would have formed. So what's the probability that the atheist is right in this particular case? Now, that's a bit of a rhetorical thing there, all right? But I wouldn't want to go for that one. By the way, I do believe when mathematicians define the number 0, essentially they're saying, in terms of it could happen, it's something like that. All right, but it turns out, if you start looking a little bit more closely, what you find out is virtually every single parameter that defines how the universe works, the nuclear strong force, the nuclear weak force, the electromagnetic force, the amount of electric and positive charge, et cetera, et cetera, et cetera, et cetera, et cetera. For all of these things, you change them just a little bit, and there'd be no life, et cetera. For example, this is just, it keeps going. If you change the size of the nuclear strong force, that's the one that joins protons and neutrons together. A couple percent larger, no hydrogen, no stars, no life. Couple percent smaller, only hydrogen, and no larger elements, no life. The nuclear weak force, that's the one that joins the electrons to the protons to make a neutron. Change it in either direction by a couple percent. The electrical force, change it by a few percent. Either no chemical bonding or no chemical bonding, et cetera, et cetera, et cetera. At some point, the case for this to be a random set of processes without design, without designer, it becomes irrational. In fact, I believe it is either irrational or certainly it borders on irrational, unless there's some other principle that we don't know about that could explain such a thing, but that would be complete speculation. Now, again, physicists created this steady state model to save the eternal universe, which was destroyed by later evidence. So naturally, those who want to save their chance random universe model here, they had to do something, so they came up with this multiverse theory. So this theory goes something like this. There's an infinite number of universes, and we just happen to live in the right one. Now, that does not meet the minimum specifications to be a scientific theory. Because a scientific theory, in order to be scientific, has to be supportable by experiment and refutable by experiment, and that theory is neither. In fact, there is no evidence for this theory. In fact, the only reason this theory exists, I believe, is to save the atheistic perspective. Now, I might be wrong about that, but that's what I think. And feel free to ask questions then. By the way, of the two sessions, the one that's probably going to raise more questions probably be the first. Did they have some sheets of paper out there yet? So you might forget. I have that question. I won't forget, but you might forget. So write it down if you want. Okay, great. Now, I'm a scientist. I'm an experimental scientist, and you know, one of the things I would do is we'd build our instruments, and we were trying to line up an ion beam with a laser beam inside of a can where you couldn't see, and it took us between 6 months and a year to do it. The reason is we had like 5 or 6 different parameters we had to get just right, within 5% or less at the same time. But we're talking about getting something to 1 part in 10 to the 60th, something else to 1 part in 10 to the 20th, and 27 other things, all just right, all completely at random, because it's not like we were making that instrument work at random. We were designing it. All right. Fred Hoyle said, a super intellect has monkeyed with physics, chemistry, and biology. I agree, all 3. I haven't even talked about biology. Okay, great. Now, I'm going to skip a bunch of stuff. Anthony Flew, that's pretty cool. Right galaxy, right place in the galaxy, right star, right place in the star. But, why? Because I said I'd be speaking for 45 minutes. And you can ask questions. Okay? Like I said, 2 parts to this initial discussion. I would guess I went about 25 to 30 minutes so far. Okay, so I got to move on a little bit. I want to talk a little bit about why in particular the God that's described in the Bible. Now, I would say this. The evidence that the God of the Bible is the real one, of that evidence from science, it's like this little tiny, tiny piece. It's just a tiny, tiny piece. I'm going to talk about some other evidence for the Christian God as opposed to just some other idea. What we've established through part 1 of this talk is creator, designer, very smart, and very powerful. That's what we have. So fine, which designer, does that designer even reveal himself? Maybe we have deism. That's Einstein's perspective. So I want to tell you why, even from a scientific perspective, I say the one of the Bible. Here's Dallas McCown, a famous biologist, evolutionist, and an atheist. He said, Christianity is scientifically unsupported and probably insupportable, philosophically suspect at best, disreputable at worst, and historically fraudulent. Well, there you go. Obviously, and any smart person agrees with this. Obviously. Now, excuse me. Historically fraudulent. All right, so what are these errors, historical errors in the Bible? Which ones? Has Dallas McCown even checked out this claim? I don't know. I'm not sure. But I don't know of any historical errors in the Bible. I haven't heard of one. I've certainly gotten a lot of questions on that. Philosophically suspect at best. Now, I don't know. I would take on atheism as a philosophy compared to the Christian idea. I would take that on any level. That's another talk. Come back next year, I'll do that one. Easy to say, harder to prove, that's for sure. Scientifically unsupported and probably insupportable. Obviously, everybody knows. Anyone who's a scientist couldn't believe the Bible. I was going to a conference. We were in a van with a bunch of science professors one time, and this lady spoke up boldly, assuming obviously everybody would agree. She said, how come Christianity, what a stupid religion. I can't believe anybody believes that. Oh, my goodness gracious. So, for example, it says in the Bible, if somebody wears clothing with one or the one material, capital punishment. What a stupid religion. I said, excuse me, but the Bible doesn't say that. She said, yes, it does. I saw it in a website. Typical. One thing she didn't see it in is the Bible. I said, people say there's all these science errors in the Bible. I've read it through at least half a dozen times. I haven't found one yet. I don't know what they're talking about. It got really quiet in that van. Then I pulled out my Bible. I opened it to Leviticus. I didn't know chapter and verse, but I knew it was on the right-hand side of the page, halfway down. Little prayer, found it. And I read that scripture. And I said something like, I wish people wouldn't criticize the Bible. They'd know what they're talking about. But that's typical, especially at the university. There's this idea, Christians, well, whatever, I protest against that. I don't agree with that at all. I don't agree at all. Now, like I said, by the way, the Bible is not a science book. I like Galileo in that. He said, the Bible is written to tell us how to go to heaven, not how the heavens go. It's not intended to do that. The Bible is not a science book. It's a God book, and it doesn't speak to science very much. But the few times it does speak to science, my experience is, it's right. So I'm just going to talk about a few examples of that. This is the Papyrus Ebers. Can't really read it. Oh, it's in hieroglyphic anyway. Written in 1500 BC. And it's a compendium of the knowledge of medicine in Egypt at the time. Ancient scholars of the ancient world will tell you that probably the Chinese and the Egyptians had the most advanced scientific knowledge at the time. Let's look at some of the prescriptions of Papyrus Ebers. 1500 BC, roughly the time that Moses lived, which is going to be significant. All right, so here we go. To prevent hair from turning gray, anoint it with the blood of a calf, which is boiled in oil, with the fat of a rattlesnake. Okay? You obviously have not been using that stuff. All right. Mixture of 6 fats: hippopotamus, horse, crocodile, cat, snake, and ibex, to prevent hair loss. And clearly we have somebody here who's not using that. Now, I guess that was to make the men more attractive to the women. Women, would you hang out with a guy with that stuff? It's funny, but actually, it's not funny. It's tragic. The average lifespan was 20 years. Not because people couldn't live to be 80, but because almost everybody fell to some kind of infectious disease. Let's look at some of the prescriptions in Papyrus Ebers. Lizard's blood, swine's teeth, putrid meat, moisture from pig's ears, human excrement. Got an infection, smear some of that on there. Let's go from there. Okay. And by the way, I'm sure some of the medical knowledge in Papyrus Ebers would actually work. I'm not saying it's all junk. Okay, I'm not saying that. But clearly, this is human knowledge. Here's my point. If Dallas McCown was right, and if my friend in the van was right, the Bible would have stuff like this. Guaranteed. It's got a lot of medical kinds of advice. Let's look at some of that advice. Here's the statement, Exodus 15:26. God says to his people, if you obey the laws I'm giving you today, I will not bring on you any of the diseases of your neighbors. All right, let's think about the cultures that have been around for 3,500 years and still around. Chinese, Egyptian, maybe Hindu, and the Jews. They don't seem to fit into that group very well. Didn't exactly have a stable homeland. But I believe because the Jews obeyed God's commands in these areas, they lived longer, they had more children. Let's look at some of them. For example, in Leviticus 11, it's quite specific about the kinds of meat you can and can't eat. Pig, no. Beef, yes. All right. Shellfish, no. Fish with scales, yes. Carnivores, no, etc. Now, it just so happens every single kind of meat that is outlawed in Leviticus is relatively dangerous to human health. Every single kind of meat that is allowed in Leviticus is relatively safe to human health. Which would you rather eat, raw beef or raw pork? That's pretty clear. Now, with the kinds of things they do today, pork is relatively safe compared to back then by far. But there are 22 known diseases, most of which are fatal to human beings in pork. Now, cook the pork almost all the way. I was in Venezuela a few years ago. I offered off the menu. I speak Spanish, but I didn't know what the stuff was. I said, just bring me that, please. Whole plate of raw beef. All right, Leviticus 11? Yeah. Okay. Raw clams? Tastes good. I grew up with them. Raw fish with scales? Sushi? Safe. Now, if this was the only example, I would say to skeptic has some room. Come on, some room there. But here's the fact. All the people ate all these other foods. And the Jews did not. And I'll guarantee you, many, many, many were saved from death from that alone. Let's look at another one. All right, by the way, this is taken from Jewish writings. Again, to establish the idea, if the Bible were the work of human thinking alone, these are the kinds of things that would be in there. Let's look at the second one. The gnat, feeble creature, taking in food but never secreting it, is... Wait, let's stop right there. What they're claiming is flies don't have poop. Is that true? No, that's a science error. Now, I'm a scientist, and I read things skeptically. I read the Bible looking for these kinds of things. I haven't found one yet. Not one. And I challenge anybody to prove me wrong on that. Okay? Anyway, reading along. All right, so never secreting it is a specific against the poison of the viper. So you get bitten by a poisonous snake. Now you have to gather up the flies ahead of time, because once you're bitten by the snake, so I guess they kept it in jars, crushed it up. I don't know. Here we go. Next one. Whoever touches the dead body of anyone will be unclean for 7 days. He must purify himself with the water on the third and seventh day. Take some hyssop, dip it in the water, sprinkle the tent and the furnishings of the people who were there. Okay, great. So what the Bible says is, if you touch a dead body, you are unclean. Ceremonial unclean, and have to be separate from everybody for 7 days. Harsh, cruel. What that means is the one who takes care of the body can't attend the funeral. Nothing. Why would God do that? I don't know. In all these laws, God doesn't say why. He sort of doesn't say because of the microbes that exist in a dead body. Ignaz Semmelweis, Hungarian. I was teaching this class in Hungary, and I said, Serbian. Afterwards, they said, Hungarian. I said, are you sure? So they took me to his house. So he's Hungarian. He's working in a hospital in Vienna. It was a woman's hospital. 18% of the patients that were entered the hospital died in the hospital. They got what's called puerperal fever. The doctor said it was bad air. They said it was the women were hysterical, typical male attitude there. They had no answer. Semmelweis said, anybody who touches a dead body is unclean, and they have to wash themselves with soap and water thoroughly before they touch any of their patients. Death rate went down to 4%.
Wow.
Now, the Bible has another rule that I'm not quoting here, which says when a woman gives birth, she's unclean. Why would God do that? Because He hates women, obviously. No, because He loves women.
Amen.
And when is a woman most susceptible to deadly infections? When she gives birth. And even when she has her period, to a lesser extent. How many women's lives were saved by that? So again, this was a woman's hospital, so Semmelweis said, whenever you touch even a living patient, wash your hands carefully with soap and water. The death rate went down to 0.5%.
Wow.
Now, they should have had a marching band and declared him the national hero. Instead, they fired him, and he died of an infection. Now, the formula was this: hyssop, ash, and water. Hyssop is in the thyme family, T-H-Y-M-E, and it's a very, very oily plant. The oil from the hyssop, the ash, and the water makes soap. Yeah. But it turns out hyssop is a special plant because the oil of hyssop contains 10% thymol. All right? I teach organic chemistry, and this is in the group of organic chemicals known as phenols. And the first property of phenols, I tell my students, is they're unique in this. They are not poisonous to humans, but they kill bacteria. So God's formula when you touch a dead body was to clean yourself all over on the third and seventh day with a powerful antibacterial soap. Okay? All right. Skin diseases, specifically, I would say probably leprosy would fall in this camp. God had another cruel, harsh, horrible, hateful thing, which is when somebody has these skin diseases, they have to be separate from the people till the day they die, unless there's evidence they're completely free of that disease. Another hateful and horrible thing. Okay, possibly. Now, leprosy was the most feared disease in the ancient world, not because it killed the most people. Yellow fever killed more people, malaria killed more people, typhus killed more people, cholera killed more people, but it was the way that leprosy killed people, because it was just the most horrible, horrible way to die. Medical science proposed things like the alignment of the planets and eating hot food. If that's true, then how do they have leprosy in India? I don't know. Okay, Leviticus simply said they must live outside the camp. In the 16th century in Scandinavia, there were a group of monks that thought, let's just try it. Let's try quarantine. And within 2 generations, leprosy had virtually disappeared in Europe, simply by following the biblical command. Again, in every case, God didn't say why. He didn't say because leprosy is an infectious disease. And interestingly, each one of these commands, not only did they create health, they also had a spiritual meaning, which is pretty cool. Same with this one, the life is in the blood. Can you see a possible spiritual symbolic meaning behind the statement that the life is in the blood? Yeah. I could as a Christian, for sure. Now, medical science, you know what the most common medical treatment in the 17th and 18th centuries was, even into the 19th century? Bloodletting. Because the current scientific knowledge was unanimous that when you have an infectious disease, the disease is in the blood. The Bible said the life is in the blood. Medical science says the disease is in the blood. Which is right? The life is in the blood or the disease is in the blood? The life is in the blood. In the 1850s, this thing called my brain stopped working. The thing that defends against diseases. Your white blood cells. Immune system, thank you. Immune system. There it is. It's been a long day.
You do great.
Immune system. Anyway, obviously, I assume you know the immune system is in the blood. The worst thing you can do if you have an infectious disease is drain the blood. Last example. There are more. Just last example to get the idea. All right, circumcision on the 8th day. God said, circumcise every male child on the 8th day. This is not even in the law of Moses. This goes all the way back to Abraham. All right, 2 questions. Number 1, why circumcision? And number 2, why the 8th day? Bible doesn't say why. Here's the principle. The Bible says it. Do it. Even if you don't know why, and even if you're tempted to think it's not a good idea. In these cases, that kind of works. So why circumcision? I don't know. But I do know this, that bacteria and yeast are how most people died back then. And bacteria and yeast love warm, dark, wet places. All right. Where's the warmest, darkest, wettest place on a guy? Well, it depends on whether you have that little fold of skin or not anymore, okay? Let's skip the details. And interestingly, circumcision saves more female lives than it saves male lives. Did you know, multiple studies have shown 60% drop in the spread of AIDS simply from male circumcision, to the point where throughout Africa they're starting widespread male circumcision programs for that very reason. So, and not just circumcision. Now, in today's hygiene, guys, you take a shower on a regular basis, the relative health benefits of circumcision are less other than maybe the AIDS epidemic. Christians generally don't have to worry about that so much. All right, I don't want to minimize that. But anyway, so circumcision. But why the 8th day? Why the 8th day? Again, I don't know. The Bible certainly doesn't say. But let me tell you why I think, at least one of the reasons. Turns out, prothrombin is the protein necessary in order for blood to clot. Now, in order to make prothrombin, we need vitamin K, but vitamin K does not pass through the placenta to the baby. Simply doesn't. So when a baby's born, if you were to circumcise them, the chances of them bleeding out would be very, very high. Very high. And actually, the prothrombin actually drops in the first 2 or 3 days of life because there's no vitamin K. Baby eats from mommy, gets lots of bacteria. Bacteria goes to the large intestine. Almost all the vitamin K you have comes from the bacteria in your large intestine. One reason to be careful about how much antibiotics you take, by the way. Anyway, not a problem today. Baby's born, vitamin K shot, good to go. Now, it turns out what happens is the baby gets the bacteria. They grow like crazy. The prothrombin level goes to unnaturally high levels, and then it drops back down to normal levels. I'm going to show you a graph of level of prothrombin versus time from the birth of an infant. Here it is. And guess what the safest day is to circumcise a baby? From the moment of birth to the moment of death. 8th day. The 9th is just as good. 7th, absolutely fine. All right? Accident? I don't know. But people say, the Bible is, scientifically unsupported and probably unsupportable. I say, all right, where are your examples? I mean, people say that. I just don't know any examples. So let me end. Let me see. I'll skip that. Actually, I'll just stop there. So normally I'd stop and do some question and answer, but I think I talked my full 45 minutes. I think I did. So we're going to take a 5 or 10 minute break. Good.